Greetings, everyone. My name is Frank Daniel Moenvedvik, and I am delighted to invite you all to this very first session of Pixapalooza, where we, over the next week or so, will be teaching you all about Pixatope, how to utilize Pixatope in your virtual productions, as well as how you can use Unreal to elevate your virtual productions to the next level. And now, before we begin, I would just like to say that I'm sorry that we were unable to do this in person at NAB, which, as you all know, none of us were able to make for circumstances we are all far too aware of. So instead, we do hope that this web-based seminar will prove as a sufficient substitute instead. Please note that in these sad days, everyone in the world is currently doing similar things online. Everyone's streaming data and everyone's doing video conferences. So quality might suffer ever so slightly. Therefore, as you can see, we currently have 3 different video feeds. You, of course, have this handy webcam, so I can make eye contact with all of you. On my right-hand side, this side, you'll be seeing a live SDI output feed from my display. This has been converted to a webcam in order to ensure that you can see a fairly smooth frame rate, but probably with some compression artifacts. And directly below, you'll be seeing my actual screen share, which is going to be much higher resolution, but probably slightly more stuttery in frame rate. You can choose which feed you would like to be focusing on simply by clicking in the bottom right corner of the respective feed and full screening it at your leisure. So before we dig into deep into Pixatope and this first session, which is going to be a brief, not so brief introduction into Pixatope as a suite, first a little bit about me. My name is Frank Daniel Moenvedvik, and I am a senior product specialist at the Future Group, where I worked for the past 3 or 4 years. During that time, I've been traveling all over the world and probably been working at almost every single production where Pixatope and its precursors have been used. I've also had the great honor and joy of probably working on site with quite a few of you who have been joining us today. And those of you I have not yet met in person, I'm hoping I'll be able to make your acquaintance in the near future. I also travel a lot for all kinds of demos and different broadcast shows, so I probably had the chance to say hello to quite a few at those events as well, but sadly not this year. In the past, I worked as a freelance character artist, and before then, I did a brief stint in the game industry. But that's enough about me. Before we dive into the schedule and start going through the do's and don'ts of Pixatope and what the program actually is, please remember that you are all free to ask questions at any given time. My colleagues will be answering them one-on-one as you ask them. And at the end of this session, we'll be doing a Q&A where I'll be going through all the different questions you asked in plenum. So this is the first day of Pixapalooza, where we'll be doing an overview of the Pixatope director, editor, its features, as well as looking at some rather snazzy looking graphics. Over the next week, starting on Tuesday, we'll be doing more of a deep delve into augmented reality, how to set up an AR set from scratch, and how to take it a bit to the next level with virtual characters and how to control them. On Wednesday, we'll be taking this a step further with virtual studios and all the exciting things you can do with a virtual set. The virtual studios can be so much more than just a very expensive matte painting, which we are hoping to be able to convince all of you of on Wednesday. On Thursday, we'll be doing more of a deep dive into how you can control your graphics, either using the Pixatope control panel interface or more esoteric ways of interacting with your graphics using data integration, using our event system, using typecode, and so on and so forth. Before we do on Friday, a deep dive into creative workflow, asset management, revision control, as well as style guides, how to use them, what they are, what's the importance of using a style guide. And we'll be moving on from there to the logical next step, which is general best practices and how you actually get your stuff done in the deadline you have available. Next week on Monday, we'll be doing more of a deep dive into performance. One of the most important things in virtual production is to ensure that your real-time graphics are actually real-time and hitting your target frame rate budgets, which will be the focus of next Monday, in that we'll be looking at optimizing lighting, how to profile your performance, how to do general optimization, and what the typical bottlenecks in real-time graphics tends to be. We'll also be looking at some more advanced render features in detail, including different ways of doing reflections, ray tracing, as well as video playback within Pixeltope. And to wrap it all up, on Tuesday next week, we'll be finally doing a deep delve into Pixeltope from more of a broadcast point of view, as in how would broadcast engineers and broadcast technicians fit Pixeltope into the whole broadcast or studio infrastructure, as well as what this entails, what considerations you have to make in order to do this in the most clean, organized way possible. Tuesday next week will also be a deep dive into our internal chroma keyer, how to get the most value out of the chroma keyer, and what you have to do to ensure that your physical green screen is in the best possible shape it can be to ensure you have a clean, useful chroma key. We'll also be looking at garbage masks, render layers, and some in-depth in post-processing, just to wrap up every possible facet that is worth covering during Pixelpalooza. So, what is Pixeltope? I believe that is as good of a place to start as any. Pixeltope is a virtual production solution built on Unreal Engine 4. It facilitates photorealistic, lightning-fast mixed reality, both augmented reality and virtual studios, as well as anything anywhere in between. So we can actually, if we change the output feed on our side camera, we can actually see Pixeltope running on the side. We have our handy mascot Dot waiting patiently for us to be ready to dive into the editor. But first, let's wrap up this segment. Pixeltope as a solution was officially launched roughly this time of the year last year, just before NAB, and has since then been used by several of our creative partners, as well as other companies, in live broadcasts and productions, which have been seen by hundreds upon hundreds of millions of people all over the world. Just to name a few, Pixeltope has been used for augmented reality in Super Bowl 2 years in a row. Most recently, which 2 months ago, where the Famous Group did a stellar production where they did a 6-minute long live-to-air augmented reality production celebrating the sort of the all-time team or Hall of Fame of the NFL. We also were involved in Eurovision, which was the spring of last year, where Pixeltope was used for several different bits of augmented reality graphics, as well as recurring title postcards throughout the show. Pixeltope was also utilized in the League of Legends World Championship, as well as the qualifiers over the last year and a half. There's also been several medium-sized events and big events as well, like the Red Bull Rampage event in Utah a few months back, and the Baltimore Ravens in-stadium AR segment where they had their mascot, a giant raven, fly in and scare the crap out of everyone in their audience, which was a quite spectacular production. So, Pixeltope is built on Unreal Engine 4. It is not a plugin, but a full custom build of Unreal. This nets us a large amount of different benefits, and we'll be diving into those into a second. Before we dive too deep into that, let's introduce the studio environment where we are going to be spending the next week and a half together. So given that we have almost nobody else sitting in the office these days, people are working from home for one reason or the other. So we actually went ahead and converted our entire office space into a makeshift studio. So we are, throughout Pixelpalooza, going to be using an AR studio area, which is on this other side of my desk, which you are seeing here at my side. The camera used there is fairly standard. I believe it's a Panasonic. It's a Sonic camera mounted on a Moses mechanical tracking tripod solution. Whereas over in the green screen at the far side of the studio, we have, is that another Sony? Canon, sorry. That's a Canon, sorry. Mounted with an NCAM optical tracking system. All of these are feeding tracking data and SDI feed into a single render engine. And we'll just be bouncing back and forth between these video feeds as we bounce between AR and Virtual Studio throughout the next few days. So, Pixeltope consists of two main interfaces. The Pixeltope Director, which we can see here. There we go. Oh, there we go. Which is sort of your landing page and the first thing you'll see after you install and log into Pixeltope. And then we of course also have the Pixeltope editor, which we have running here, which is our custom version or custom build of Unreal Engine 4. Now, before we do a deep dive into the editor, we do have to briefly cover the director, just because so we know kind of what's going on and what the purpose of this interface is. So the director has been developed as we realized we needed sort of a one-stop solution to do all our technical setup. The director is split into two main segments, the Setup tab and the Production tab. Setup is where you'll do sort of your one-off initial configuration of your studio setup, whereas the Production tab is where you'll be operating your graphics and where operators and people who doesn't necessarily need to or have a real experience will still be able to sit and tweak and handle and operate the graphics on the fly during rehearsals as well as during live broadcast. Now the Setup tab is a one-stop interface where you'll be handling your network routing, your tracking data, your signal routing, as well as your tracking calibration and offsets. And it also has utilities for offsetting, debugging, and manually feeding tracking data if you so choose. From top to bottom, we'll start here. At the top, we have a launch pad where you can simply launch your different levels and projects. You can see we only have one project mapped, our Pixelpalooza project. And within that, we can see every level residing in this project, as well as a few control panels. I'm just going to filter out the levels we are actually going to be using. Most of the other levels are just sub-levels, which are used indirectly in one way or another. Below the launch menu, we have our General Settings tab, and this is simply where you add your projects, as well as set some of your default parameters. Now, adding a project is pretty straightforward. You simply map to the project you want to add, and you add it here. It's worth mentioning that these projects can easily be sort of standard Unreal projects. They will open and run in Pixeltope perfectly fine off the bat without any conversion or processing process. We can open Pixeltope projects and Unreal projects just like that on the fly. We can here below also set our default input and output formats. These can be overridden later on, but since we generally tend to be using 50p, 1080 50p in our studio, this is what we have calibrated by default. But if we click this, we can see that we support both progressive and interlaced, all the way from 720 all the way up to 4K. Lastly, we have this exciting checkbox here, DX12 mode, which allows us to use real-time ray tracing, which we're going to spend some time looking at today. In the Network tab, we can see we have a few different submenus. We have our Data Hub, our camera tracking servers, and our render machines. Now, if we take a quick glance at our diagram, we can see that we have two render engines connected. We have one engine over here, which is simply passing through tracking data, and the actual machine I'm currently sitting on, which is our demo machine. The demo machine is desktop, whereas Studio Render 1 is a render engine sitting over in the green screen studio, which simply passes on its tracking data to me, so I'm able to utilize both camera feeds on the fly. So from the top, we have the Data Hub. The Data Hub is actually a very important service, and it's important to understand its function. The Data Hub acts as a post office in many ways. It's a service that has to run on a single machine, and it allows all your different render engines and Pixeltop interfaces to connect to each other through the data hub. So it simply passes messages. It doesn't store any data. It's not a server. It is just a communications hub. Through the data hub, we are able to control any render engine from any Pixeltop director connected to the same data hub. Below the data hub, we see we have a camera tracking servers. These run on each individual machine just for safety reasons. So even if the data hub were to go away, you still have your tracking data coming in and your video data coming in, so your render engine will still be live. And then, of course, you also have our two render engines, which was just discussed. And clicking this tab at the bottom shows us the current status of everything connected to Director. So we can keep going. We're going to speed through the camera setup, which will be covering more detail tomorrow. This is where you'll be setting up your actual cameras and your input-output routing. You simply add a camera system, you give it a name, you choose the film back if you need to have very precise depth of field and defocus. Generally speaking, we tend to leave this as is because we will very rarely have the need to have those last % of extreme defocus accuracy. But if you need it, this is where you could go ahead and facilitate that. You probably see every single camera model you've ever heard of in here. Next up is tracking. So you can see that we have two camera systems, the green screen camera and the bright side camera over here, which are using the respective tracking protocols. So from the drop-down, you can probably see quite a few familiar product names and company names. We support all the large tracking solutions and tracking companies on the market, from Moses to Stipe to 3D to SMT to Trackman to Technocrane. We also support quite a few other solutions through the sort of open 3D solution, as well as our integration into, well, our being able to take in the ROS UX protocol. We also have the option of feeding in manual tracking data if for some reason we just need to manually position a camera somewhere, or if we don't have an actual tracking solution available. We'll be diving into these sort of advanced menus later, but the last step to set up your tracking is to ensure that you've routed your tracking data or your tracking server to a particular camera, and this is what connects a camera feed to a stream of tracking data and making them live together. So you can see these have already been assigned. We have assigned a tracking server to the different camera systems. We've given them the ports that we're expecting to receive the tracking data on, and we can see that we are actually receiving live data. You can also see this in the editor interface in the top right. We can see we are connected to the data hub, and we can see that we have tracking data coming in. And if my colleague Magnus were to wiggle the camera, we can see the tracking data update, and we can see the tracking works as intended in the editor. We can even jump out of play mode, and if we keep wheeling a camera, we can actually see the representation of the tracked camera move despite us not being in live mode. We can also see, even more interestingly, that here on my side, we still are getting a live final composite output despite me not being in live mode. That is because we have VisuVig enabled, meaning that in a fashion we are always live. I'm actually able to sit in the editor working, moving objects around, and you'll be seeing these pop up in the final composite output on the fly. The VisuVig utility is incredibly powerful and useful, and we are going to be spending a lot of time on that in a few minutes. Just to wrap this up, we also below, now that we're done setting up our tracking, we also have our video input output and routing tabs. This is where you'll first start by defining which inputs are you expecting to have and what are those inputs supposed to be. As an example, our green screen video feed is of course going to be using our internal keyer because it needs to be chroma keyed. It's a green screen video stream after all. Whereas our AR camera is just a camera, it doesn't need to go through a keying process. So we simply have that set up to be an input camera. We can also add more inputs, which could for instance be just a video stream that we want to use as a media input on a virtual monitor, or it could be a two separate video feeds for external key and external fill if for some reason we would like to use an external chroma key. And lastly, we also defined our video output, which is, again, you just make an output and you choose the format and the color space. Notice that we can set color profiles and color spaces on all our inputs and outputs. This is brand new in this build of Pixeltope, which is Pixeltope 1.2, by the way. We didn't mention that earlier. This is Pixeltope 1.2, our newest public release, which is based on Unreal 423. And one of the brand new offerings in this build is our HDR workflow. Very exciting stuff. We'll be touching more on that once we start diving into the composite. Now that we've defined our input and output signals, then we just go to routing and we assign the actual physical spigots that these signals are supposed to come in and out on. So we can actually see here that if I jump into live mode, that was very loud. We are outputting all different Pixeltope as well. Let me just mute that, there we go. So here we can see that we obviously have an AR backdrop, but there's nothing here stopping me from saying, you know what, I don't want to route that. Instead, I want to just route my green screen footage instead. So I just changed the input camera. And within a few seconds, we'll now be seeing a different camera input instead, together with its respective tracking data. Very cool stuff. But now we are going to be starting out in AR, so let's quickly change this back. The input output routing panel is also where you set your gen lock. We support both blackburst and trial level on a dedicated SDI feed or reference feed, but we can also use the actual SDI signal itself and simply base our sync on the frame rate of the feed coming in, which is what we are currently doing. We have set the gen lock to the respective SDI feed just to keep things a bit simple. And that is more or less your setup. I hope you're all convinced that this is fairly easy to click on through, and we can, using this interface, do things in hours, if not less than an hour, that previously would take us days. So let's move on to production. So the Pixeltope editor, as opposed to the director, which is mainly for technical setup and used by operators and people who might not necessarily need to have a lot of know-how in Unreal, the Pixeltope editor is designed and built to be used by artists and technical engineers. It's also useful for people who are working with tracking, just to quickly get in some tracking utilities and calibration utilities to verify that the tracking is sound. But in short, the Pixeltope editor is used to create graphics and interactive logic in a very familiar Unreal 4 interface. It's also built to be as user-friendly as possible to people who might not necessarily have a lot of background in Unreal. Yes. So let's take a cursory glance at the editor assuming that we have a little bit of Unreal experience. To most of you, this might already be a very dear and familiar UI. You might realize that this is very similar to standard Unreal, except of course it has been tinted a lovely shade of Pixeltope blue. And there's also a few new little windows and buttons that we might not have seen or that we might not already be familiar with. So let's quickly take a look at what's new in this interface. So in top right, we already covered the tracking window. Directly below that, we have our adjustments tab. Now, what this does is showcases that we've made some adjustments to our graphics from the Pixeltope director. So I'm going to go ahead and remove whatever adjustments I made, and we will walk through this from scratch. So a typical use case for our adjustments logic is, let's say you are about to go into rehearsal, you're about to go live, and God forbid you have an artist that accidentally has left a piece of geometry in your scene that is not supposed to be there. And you are now live across 5, 6, 7, 10 different render engines. You're cutting to AR in 30 seconds, and suddenly somebody screams out, "There's a cube on the floor." it's occluding everything, it's ruining everyone's good time. What do you do? Well, then you can dive into the director, jump to the production tab, and we will jump to the first adjust submenu, adjust object. So go ahead here and adjust an object. Notice that we, despite not having actually exposed this cube, we are able to access every actor in the scene on the fly, which is facilitated by the fact that we are a full custom version of Unreal. We're building Unreal, and we're not just sitting on top as a plugin. So we have complete control of everything happening under the hood. So here I can then grab hold of the cube that we just created. I could, for instance, go into, oh, that happens when you wiggle a interface. I could select visibility, and I can toggle visibility on and off. We can see that was actually the wrong cube. Not to worry, we can easily click our way through. I can actually assume it's going to be this cube, which is not an AR shadow catcher. And just like that, we've gotten rid of our cube. And we have done this across all our different render engines because this operation can be sent to multiple destinations at the same time. Another use case might be that this cube is a logo or a piece of graphic you might want to have, except maybe you have a tripod center in front of your talent, whereas a jib off to the side is being occluded by a scoreboard. You might want the scoreboard from your main camera, but you might want to hide it only on your side camera to ensure you have a clear shot of your talent. Again, using this interface, you can easily toggle, move, or scale, or adjust things per individual render engine on the fly. I could also go into mobility, and I can say, I want this piece of geometry, I'm just going to shift it off to the side. As you can see, I can even click in here and start scrolling the mouse wheel just to do it a bit faster. And here's the really interesting thing. We can see now that we move this object off to the side. The moment I hit this escape to leave live mode, the object snaps back to its starting position. The reason for this is that everything we do in the director under the production tab is generally speaking going to be adjustments. Adjustments are non-destructive additive offsets to parameters, scalars, variables, whatever that sits on top of whatever you have saved before in your level. This means that I could, for instance, at the end of a rehearsal where we did lots of changes, afterwards I could go in, once things have calmed down a little and the technical director is no longer screaming at me over the intercom, I could dive in here, I could just simply read through my scene, and I can start looking at everything we've chosen to adjust. Inversely, I could just say that everything we did was rushed. It was probably not safe. It's probably not safe to bake it into our revision control. And I could just say I'm going to remove those adjustments, and they are now gone forever. Very cool stuff. Next up, we have our world settings. Before we dive into that, let's see, this looks a bit rough, and I'm realizing this is because I have turned off ray tracing. So we can see here we have some ambient occlusion artifacts around these wheels. We have some artifacts over on the wall. And this is because this set has in particular been designed to utilize ray tracing. I will simply jump to my control panel, toggle ray tracing. And just like that, we now have far more accurate ambient occlusion, shadows, reflections, and so on and so forth. I can also see that I'm missing some nice touch shadows over here by our character's feet. I can simply jump to our production tab, move on to composite, and start adjusting our shadow composite. So I'm just going to scale this down a bit so I can have this on screen while I'm doing these adjustments. Well, that is probably a bit too much on the heavy-handed side. Let's go ahead and maybe try something like this. Let's start by taking down our Luma mask just to ensure that we are seeing the raw shadows. It doesn't seem too bad. Let's dim them a little bit. Let's enable a Luma mask because we obviously don't want virtual shadows bleeding in on top of physical shadows. As you can see here, by just tweaking my Luma mask, it now just helps offset the fade into the dark shadows on the actual plate. Let's see here. Let's give this a longer, nicer tail. You also see that this probably is a bit too harsh. Let's see, so let's just go ahead and dial this down a little bit. And just like that, we now have something that looks slightly more level with the rest of the shadows in our scene. Very cool stuff. So now we can really see the difference between ray tracing off and on. Notice that the shadows, which here are not ray traced, so they have a uniform intensity. These leaves just leave a very stark print on the back wall. Enabling ray tracing gives us a correct softening and just makes everything look a bit more bang on. Could you possibly zoom in on Dot? Just frame him. Just zoom in all the way. Just hold it there for a second. Stop. So as you see, we enable ray tracing, which just really helps elevate the visual fidelity to the next level. If you also pull the defocus, just to showcase that, we are using a mechanical tracking system, which is MOSIS, which is feeding us decoder data from the lens. And using a calibrated lens file, we're also able to get correct defocus on our graphics, which matches what's happening with the physical video. Very cool stuff. It's worth mentioning that ray tracing is, of course, very performance heavy. We are running this on a 2080 RTX Super, but we're still getting a very acceptable 50 FPS performance. It's also worth mentioning that ray tracing can be a bit unstable. So for segments of today's session, I will be turning it off just to ensure we don't have any rude interruptions as we're looking at more elaborate virtual sets. Thank you. We can just pull back out in the wide shot. There we go. So moving on, we have in the world outliner itself a few actors which are critical for the function of Pixitope. I'm just going to go ahead and bake the shadow settings I just included, just to ensure we have these stored permanently. Very cool. So these actors are responsible for handling our camera and our camera tracking data, as well as ensuring that our custom pipeline functions as intended. These actors are, in no particular order, our camera root, which you can see over here. The camera root acts as the 0 point for our tracking data. The offset between the camera root actor and the tracked camera actor is simply going to be the actual tracking data we receive. Moving or manipulating the camera root is the main way we will be moving around in our virtual sets, together with virtual camera moves and other ways of jumping or flying or teleporting from position to position, typically in virtual sets. Tracked camera itself is, as the name implies, a tracked camera. Let's get this out of the way. If I try to move it, you'll see I will have very little success because the tracked camera only cares about the tracking data. Other actors which are important to note is the post-process handler, which is a custom version of the standard Unreal post-process volume, which has a few interesting little tidbits built into its details tab, which helps regulate and control parts of our composition pipeline. Speaking of our composition pipeline, we also have our material handler, which is simply an actor that deals with ensuring that our pipeline happens in the correct order. And this is also an actor which you can customize if for some reason you wish to change the standard Pixitope composite pipeline. It's also worth mentioning that all of these actors are spawned automatically. If you open native Unreal scene in Pixitope and hit play, Pixitope will generate all of these actors for you just like that on the fly. So you don't really have to worry about memorizing them or knowing exactly what they do, unless for some reason you need to start interacting with them. Next up, we have in the world settings. You might see there's quite a few new Pixitope related tabs. These mainly correspond to different sections of the Pixel director. For instance, a large part of the composite sliders and checkboxes and values correspond to input fields in VS Virtual Studio compositing and AR compositing. This means that you could, of course, choose to manually, as an artist, input values here by pulling sliders. We can see here some of the Luma mask and different shadows values I just manipulated, which are now represented here. But this mainly is just to have a way to access them to the editor. The main way to interact with this is going to be through the director interface. Under wall settings, we'll also find some useful utility checkboxes. This is, among other things, where you'll be choosing whether you're going to be using Virtual Studio, as seen here, enable Virtual Studio, or AR, as seen here, enable AR. If I were to turn this off, we are no longer in AR mode. You can also do other useful things here, like feed in a debug image if for some reason you don't have access to a currently tracking camera, which I can simply do by here going up to debug and enabling a debug video input instead of using our live video input. Very cool stuff. All right. Now, the last few menus we have to look at is going to be over here on the left. We have the modes tab, which is something that most Unreal artists are very familiar with. For those of you that are yet to do a deep dive into Unreal, the modes tab or the modes window is where you'll find all the basic actors, as well as some of the not so basic actors within Unreal that do everything related to basic whiteboxing of your levels, setting all kinds of lighting effects or straight up lights, post-process volumes to apply filters and effects to your graphics in certain regions of your maps or scenes. And all of these are structured in a very straightforward, intuitive way. And as you can see, Pixeltop has a separate tab here, which has neatly been tucked in between the pre-existing menus. This is a recurring thing in our overall design philosophy. We're striving to ensure that we stay as close to the overall user experience of Unreal as possible to minimize the proprietary knowledge you need to accumulate in order to be able to use Pixeltop. All our menus, checkboxes, sliders are seamlessly embedded into the Real interface, and some of our more complex things like our custom video pipeline, our custom composite pipeline, and our logic for setting virtual monitors, virtual camera moves, and so on, are all either built as Unreal blueprints using a few Pixeltop specific blueprint nodes, or tucked away as prefabs within engine content. So this is a bit of a segue back to the Pixeltop tab. This is where you can find all the basic actors related to Pixeltop. We can, of course, find our virtual cameras, which are used for virtual camera moves. Very cool stuff. We can see our composition planes or composition utilities. These being, for instance, our garbage matte plane, which is a garbage matte, as well as our internal composition plane used in Virtual Studios, which acts as a garbage matte, except the direct opposite. Where a garbage matte is typically you have a green screen and you need garbage mats to mask out everything outside the green screen at the top, at the left side, at the right side, and those pesky lights sticking in over green at the floor. Instead, we can use an internal composition plane to say that this is the space which is our green screen. This is what we are going to allow to be keyed and used in our composite. The internal composition plane is one of the most essential actors in setting up a Virtual Studio, and there's quite a lot of interesting things you can do with it. We also have a few handy little calibration utilities, as you can see here. Calibration cone, every tracking vendor's favorite, as well as a calibration cube when you're more concerned about checking your lens distortion and having some straight lines to help you out. We also have our off-axis window actor, which is neither used for Virtual Studio or augmented reality, but more some sort of a in-between. let's actually take a cursory glance at what let's skip ahead a bit and take a cursory glance at what off-axis camera projection is. The off-axis camera projection plane allows us to position a plane lined up with a physical video wall or a projection surface from projector or any kind of display, allowing us to render an image which can be then output to that display, allowing that display to act as a virtual window into a virtual set extension, or kind of a portal effect as we're seeing in this video here. This is incredibly useful for things like when you want to have a virtual studio behind your talent, but you also want the audience to be able to see this virtual studio, so you have to use a LED wall or a video wall instead of a green screen. So let's skip on back. Let's get back into the editor. The last actor we need to look at is our 3D text match, which is one of quite a few proprietary plugins that come with Pixeltop. This is simply a plugin that allows you to spawn, generate, and utilize 3D text for all your animated infographics, your diagrams, your side-by-side sports comparisons, your name fields. It supports every font. It has very handy procedural effects that you can apply to it. And there's logic to build up per glyph animation in and out, as well as per glyph animation offsets if you need to do any kind of text, rolling text or replacing text. So you can see the actor is quite easy to use. It can be changed on the fly using data, for instance, through our Pixeltop control panel. We can easily replace the font. It also supports left to right fonts, right to left fonts, and top down fonts. We can use Arabic fonts, Hebraic fonts, Korean fonts. It doesn't really matter. And we can easily assign materials to the different surfaces of our 3D text on the fly. So here I can just go ahead and choose a few materials just like that. There we go. You can also do things like offset the actual geometry procedurally, for instance, by adjusting the bevel size. We can adjust the thickness or changing the extrusion thickness. We can change how the resolution geometry-wise of the 3D text. And we can also do all kinds of per glyph animations, which we'll probably be covering more in detail on Thursday. The last big production where this 3D text was utilized was in the last Super Bowl, where the Famous Group used this on every single name field for their 6-minute long Hall of Fame production or air production. So this is the last window we have to look at, which is our optimization tab. We earlier briefly talked about the requirement of being able to optimize your graphics, ensuring you actually hit your target frame rates. Now, this scene by itself, as long as you're not using ray tracing, is not going to be too heavy. So we're actually going to go ahead and just jump out of the set. We're going to jump into Director and prepare for a virtual set, just so we have something slightly more performance intensity to look at as we cover the optimization tab. So I'm going to go into the Setup tab. Now, generally speaking, Pixeltop is one render engine per camera head. But for this particular demo, we're using multiple cameras through a single render engine, just so I don't have to get up so much. So here I'm just going to change my camera feed to our green screen studio feed, which is coming in on SDS Beacon 2. We're also going to go ahead and turn off ray tracing for now, just because we haven't really prepared some of our sets for RTX. There we go. Oh, So I actually accidentally launched this in live mode rather than in editor. So the difference between these is that live mode basically brings your graphics, it basically brings your Pixeltop in a dedicated on-air mode. This means we no longer have the interface around our viewport. We no longer have any way of interacting with the interface, but it also means since we are not rendering interface, we don't really have the performance overhead of doing so. So we get a little bit better performance, more stable tracking, and more stable composition. Sadly, being in this mode, we won't be able to look at the optimization tab. So let's go ahead and jump into editor instead. I'm going to give this a second. So it's incredibly fast to bring up and bring down the editor, bounce between levels, and do pretty much anything you would like to do within Pixeltop. Oh, sorry about that. There we go. So we are now in what we call sort of our template studio. This is actually one of several sets that come with Pixeltop as sort of training material or starter content, which we'll be covering exactly what you can be playing around with once you have your evaluation or first license of Pixeltop at hand. But this is at least one of these sets. It's a fairly typical Virtual Studio. It's something that quite a few of you are probably very familiar with, or at least the overall look and feel. And it's a showcase of kind of how these Virtual Studios can be used for practical purposes. But for now, let's jump to something a bit more organic. I'm going to bring up my control panel. I'm going to jump to a different set using this button here. Let me just move it off to the side before I click it. And just like that, we are simply streaming in a different level on the fly. Using Pixeltop, it's completely trivial to stream levels in and out and jump between different sets without having to take the engine down and back up. We can jump between sets as we like on the fly. Now, before we keep looking at performance and do a deep dive into the set, we can see that our talent is looking a bit green around the gills. We haven't really set a key yet, so it's all kind of stuck in whatever sliders somebody were messing with at some point in the past. So why don't we go ahead and quickly set a key just so we have something slightly more pleasing to look at. We're going to bring in the director, jump to production, and jump to the video keyer underneath the adjust tab. Now, I don't know exactly what's been done here before, so I'm just going to go ahead and zero everything out. And I'm going to hit this send key to SDI output button, which now overrides the fill with the key so I can see what I am doing. This is not going to be an in-depth coverage of the keyer. That's scheduled for several of the other sessions. We are just very quickly going to set a key and move on. But this will be covered in great detail once we have our Virtual Studio A to Z session, as well as the studio operation session next Tuesday. One of the most important things of getting a good key is, of course, to have a properly lit green screen and a properly shaded camera. That's actually where we should have been starting out. We have neither of those, as we can clearly see from this single capture frame, but we're not going to let that hinder us from doing what we can. We are simply going to mark the colors we are trying to key. So we've captured a single frame. I'm just capturing some of the different hues of green. You can also see that the floor is a slightly different shade, so I'm going to grab some of that as well. And we're going to hit initialize key. Doing that, we can see we already have a pretty good starting point. Now, there's a bit of gunk down here and behind the talent. So I'm simply going to dive in and grab some of those pixels as well before I hit update key, and that gets rid of more of those sort of stray pixels. I'm not going to worry too much about selecting too much green because it's easier to clip some of this out using sliders than it is to bring back things we've forcefully removed at our initial color selection step. So I'm going to go ahead and close this, and we are just going to clip some of our background. There we go. We can see that we have some artifacts here at the metal handles of the chair and some down here near the wheels. So I'm also going to clip a little bit of the high range. And that's looking not too shabby to me within a few seconds of adjustments. We could, of course, keep filling with this to sort of fill in some of our shiny metal spots, but generally you wouldn't really want to be having chromium metal on your green screen anyways in the first place. So we're just going to shuffle on for now. We can also see that we are cutting off our legs, the legs of our talent with our composition plane. So we are simply going to jump into a scene, grab hold of our internal composition plane, which, as we just mentioned, you can grab from the Pixeltope tab. And all we have to do is push it in or out to ensure it is the same distance from the tracked camera as the physical talent is from the physical camera. You can, of course, measure this out using a ruler of some kind, but generally speaking, you're also going to get equally good results if you just push the comp plane away until you're approaching the clipping threshold. You also see we're catching some of the light fixture on the left-hand side, so I'll trim that in, and just like that, we've scaled down and trimmed our composite plane to only frame our talent. Now, if your green screen has a more arbitrary shape, if it's a U-shaped green screen or you have particular requirements, there's nothing stopping you from using internal composition planes with different shapes, or even just using multiple composition planes at the same time. So you're now seeing our full talent. We're now going to jump back to our exterior set. And now we can finally take a little bit of a deep dive into the optimization tab. So the main purpose of the optimization tab is to be able to quickly review your frame rate and kind of see what's happening in your scene in terms of performance. We're going to make the viewport a bit bigger so we have more of a performance impact, simply because we're drawing more pixels. So you can see from our frame rate counter that we're hitting a rock steady 50 FPS, which is our budget or target frame rate. Bringing in the unit graph, we can see that it's rock steady. We don't really have any issues to speak of. And if we were to wiggle the camera, we would also see that, although I would have to send minus all the way over to the green screen, which I'm actually feeling like it, yes, please do. If you please could pan to the right and do a little bit of zooming. So before we dive too deep, we are actually going to take a little look around at this set. This is our Nydalen exterior set. It's a showcase of how you can kind of push the visual fidelity within Unreal and Pixeltope. And it's a heavily photogrammetry-based reconstruction of our neighborhood in Oslo, Norway. We actually went out and did photogrammetry capture of a lot of our neighboring buildings, which is what we're currently looking at. If you still can hear me, Magnus, could you just look around a bit, up and down, and look at the different features? Okay, so we can notice that as this camera is moving, we don't really have any performance issues. The green bar, which is a frame rate, is rock steady. Now, let's see what happens when performance breaks. If I were to say jump into a production tab and go to composite and do something like, let's say, super sample. Sorry, that's going to be under composite effects. Super sampling is the act of rendering more pixels than we need and then downsizing it to our target frame rate, which means that if I set the screen percentage to say 150%, we're now rendering a whole lot more pixels and we are now no longer hitting our target frame rate. So now we could start debugging this using all of these utilities to see exactly what's happening in our render threads, our game threads, and with our CPU. Where are we spending time? What's going on? Are we clamped by draw calls? Are we clamped by texture memory? All of this would be easy to identify using these widget buttons. In this particular case, we can, by opening unit, we can see that we are bottlenecked by our draw thread, which is this far slowest one. And if we open Profile GPU to get a breakdown of a single frame, we can see that we are currently spending about 35% of our render time or render budget on planar reflections, which are basically the reflections we are seeing here on the water. And we could then, of course, start trying to optimize this, fix it by adjusting the parameters on the planar reflection actor. For now, we are going to do a much easier fix, which is going to be dialing our screen percentage back to 100%. You can also, in emergency situations where you're about to go live and for some reason you're not hitting your target frame rate, you could go below 100% just to give you a little bit of extra margin as you are going live. Going from, for instance, 100% to an 80% doesn't necessarily have to be the end of the world. Basically means you're outputting 720 instead of 1080p in our particular use case. And going to 200% means you're running a 4K, which is probably not a good idea. Below this performance utility tab, we also have our input-output preview tab. This is mainly used where, as an artist, you might not have access to reference monitors or a way to see your final composite output. So using the IO preview, you can, at the click of a button, see the actual live SDI input feed you're receiving. In this case, it's going to be our green screen feed, but with D-spill applied. Looking very good. This D-spill could, of course, be turned on and off using our keyer, but generally speaking, you would like to have D-spill applied. Then from the masks tab, we can also see all the masks coming in. Currently, we can look at our respill mask, which we can use to fill in another color where they used to be green, as well as the actual key, which is going to be tucked away in the alpha channel. And this is pretty much every proprietary button and interface that you'll be seeing directly in the Pixeldope editor. Everything else is going to be tucked neatly away as black boxed blueprint nodes or hidden under the hood in our composition pipeline. Speaking of which, we've spent quite a lot of time looking at Pixeldope and what's new as compared to Unreal Engine 4. But from a sort of higher level, we could also do some comparing. Just to briefly outline the differences, Unreal Engine 4 is an incredibly versatile, powerful, and flexible real-time engine with a plethora of powerful tools allowing us to quickly generate all sorts of dynamic, photorealistic content and run it in real time, both as a game or in more recent years, thanks to Epic's heavy push into the broadcasting VFX sphere to make photorealistic, gorgeous, real-time special effects. What we at the Future Group do with Pixeldope is build upon this solid foundation which has been set by Epic and supplement it with our own suite of custom tools and render pipeline adjustments, as well as streamlining the process of integrating Unreal neatly into a broadcast production environment. Some of the tools we have made and that we ship with Pixeldope include, but are not limited to, our custom video input-output pipeline, allowing you to take in video and play it back without degrading it with temporal aliasing or the native Unreal composition pipeline. Speaking of pipeline, we also have a custom render pipeline, we basically spent several years heavily modifying and adjusting the native Unreal pipeline in order to ensure more efficient compositing from a broadcast perspective. Among other things, what we do is we take the video signal, bypass a large part of the degrading post-process effects like motion blur, temporal aliasing, tone mapping within Unreal. We preserve every single pixel of your video and do sort of a custom injection and composite at the end of the pipeline. We have a strong focus on keeping this as efficient and performant and stable as possible, with performance on par with what you would get out of standard Unreal. We also, of course, have the user-friendly one-stop setup interface in the director, which we've already covered and glanced at, as well as other functionality within the editor itself, ensuring that Pixeltop is easier to use and learn for non-Unreal users. In short, Pixeltop is a turnkey solution, allowing us to harness the raw power of Unreal through a user experience and a thorough systematic integration into Unreal that matches broadcast customers' needs and expectations, as well as help alleviate a lot of the headaches that our creative partners have probably suffered for years working with virtual productions. And that is more or less Pixeltop, at least at a glance. Now, let's jump back into our set and let's start looking a bit at sort of these demo sets that we ship with Pixeltop. Now, we've already briefly looked at our VisuVig utility, which allows us to generate a final composite while we are working in the editor. It's worth mentioning that this has some performance overhead because when we are using this, we are rendering the scene twice from 2 different camera angles. So generally speaking, it can be a good idea to leave it off unless you need VisuVig active for a particular reason. So I can see that we have some residual lingering hiccups from me accidentally setting the resolution to 4K. So I'm just quickly going to reboot the level. And then we're going to start looking at what these different sets can actually do. Let's see, we're just waiting for this to come back online. There we go. Now, since I didn't actually save my settings, I would just quickly have to reinitialize my keyer. But that's as simple as doing a clean color selection. And there we have our key back to where we left off. There we go. Now, the studio set has a lot of interesting, powerful functionality that we'll be covering in detail later on once we've turned ray tracing back on. But for now, let's jump into the exterior set and look at how dynamic graphics can be when created through Pixeltop. So as we jump outside, we could of course use the camera to look around, but I'm actually going to manually fly around instead by hitting F8, which decouples me from the tracked camera, allowing me to fly off on my own and take a look at kind of what's happening in this scene. So you can see that this is of course a gorgeous looking set. It's nice and summery. There's tons of moving little bits and details like these lovely rendered ducks that we spent far too much time building and animating. We have foliage moving and fluttering in the wind. We have critters and bugs just helping bring the scene to life. But this is not really an accurate representation of what Nydalen, our neighborhood, looks like at this time of year. So first of all, I can grab the sunlight because nothing here is baked. This is all dynamic and rendered in real time. We can adjust our sun to be more representative of the current time of day. There we go. And now using our director interface, we can trigger some weather effects which we have built for this particular set to bring it more to what you would expect from early spring as well as most of fall in Norway. So I'm going to go to my control panel. We're going to open control panel. To do that, let's actually go to launch. Let's find the control panel, which is going to be the weather control panel, and we're going to open it up. These control panels can, of course, be accessed through the Pixeltop director interface, but we can also access these from any web-capable device on the same network as Pixeltop director and Pixeltop Data Hub. I could, for instance, bring an iPad or my smartphone down to the actual green screen, so I could be standing in a virtual set, looking at the return feed, as I'm operating these graphics from a mobile device through a browser. So here we can see we're now in the browser interface. And clicking this, we can now bring in weather effects, which are far more likely to be seen at this time of year. So here we can see we've changed every surface, we've changed every parameter of every material to be more wet and glossy. We can here see these water droplets hitting the surface, as well as peppering the lake. And we can see the ducks have taken shelter in order to not get wet. This set might look rather dark. The reason for that is that we are currently in our HDR workflow. We are currently doing our composition in linear space, but we will not be able to see the correct color space in the editor until Pixelop 1.3 comes out. The reason for that is that we are running our input video feed through a custom color space conversion, and we are not seeing the conversion back to the original color space unless we are looking at the final output. So for now, let's take this rain back out and bring in a slightly brighter weather effect, something that people probably connotate more with Norway. As you can see, with the click of a button, bringing in the snow, we've now partially frozen over the river. We've started bringing in snow particle effects, and we've frozen over every surface in the set, from every rooftop to every tree, as well as all the foliage, which is now withered and dead, as sadly is the fate of most contemporary foliage in winter. So the purpose of this set, the reason we're looking at it, is to showcase how dynamic and interactive you can make your virtual sets. Especially now that a lot of these assets that you are looking at here, like these gorgeous photogrammetry rocks and a lot of this foliage, which has been created by our friends over at Quixel, are now free to use, courtesy of Epic, by anyone using Unreal, which means that you could easily grab your own photorealistic foliage and throw together your own photorealistic sets. Very cool stuff. Now let's jump out of this exterior set and back into our studio environment. So we're going to quickly jump out of Pixelop Editor, just so we can ensure that we have ray tracing enabled in the general setup tab. And then we are now going to jump back into the editor in our level studio, which we can find down here. Let's just filter and start so it's easier to navigate to it, and launch it in editor. As we are bringing up our studio, we can talk a bit about using Pixelop in a production environment, which of course is a very reasonable place to be expecting to see a virtual studio. Pixelop is fairly easy to slide into a typical broadcast pipeline because it's a very flexible solution. You can set up countless different configurations. What the slide you're seeing here is just one example of this. We can, of course, take in our video feeds as SDI and our tracking data over UDP. But we can also take in any other kind of data. We could take in motion capture data through a plugin which is compiled for Pixelop using our SDK. We could be taking any kind of live data feeds or data streams using our data integration through our protobuf-based API, as well as taking in video files in real time over the internet or live from disk. We can also interact with and output data in ways not shown in this diagram. For instance, outputting audio from our 3D graphics, if this is something we would like to do, which was showcased in the Baltimore Ravens AR segment, which we did which we helped the Famous Group do and put on air a few months back. We can also control things the other way around. Instead of using our API to control Pixeltope through from external data sources, we could compile a DMX plugin to control physical spotlights and physical lights as lights change within Pixeltope. We can also trigger actions and events in Pixeltope using timecode to a separate input instead of using the Pixeltope control panel or using some kind of data integration solution. So again, Pixeltope is easy to fit into a broadcast production environment, though there are some caveats and things to consider as you set up your schematics and plan out your production. Now, the starter content. We've already covered the studio set. No, sorry, we covered the exterior set, which is an outdoor studio showcasing graphical fidelity and weather effects and dynamics. Now we're going to do a deep dive into a studio set, which again is a sort of a typical Versus Studio, but we're going to see what kind of interactive behavior we can get out of a set like this. So here I'm going to just quickly align my talent. Beautiful. Let's save this position and bring this into live. So this angle by itself is not that interesting. We could, of course, go ahead and open up our director, jump over to the studio control panel, which is already open actually in the production tab. And we can start adjusting our set. The biggest issue right now is that we're not really seeing a whole lot. So why don't we just start off with a virtual camera move to pull out, allowing us to leave our talent behind and look at the studio as a whole. Very nice. Now that we pulled out, I'm not quite happy with some of the lights up here in the ceiling. They're not really blooming. They're looking a bit sort of gamey and lifeless. So I'm going to jump over to the composite tab. We are going to, sorry, the effects tab. Scale this down so it fits nicely into a single span. And we're going to go ahead and enable some bloom. Bloom can, of course, look quite nice if utilized correctly. And if we have the performance to spare, we can also hit the big drums and use convolution-based bloom, which is a more physically correct emulation of sort of the lens-based bloom you'll be able to get through a physical lens. You can even feed in specific convolution kernels to emulate specific camera lenses to ensure that your sort of these stars matches the flares you'll be seeing through the physical lens which you are currently utilizing. Very nice. Now, I'm also not really happy with how flat this all looks. It's a bit monotone and white. So we can go ahead and change our materials around using a pre-programmed blueprint, allowing us to blend all the materials to a different material configuration. I'm going to go ahead and decouple from my tracking data, just so I can fly around and see what this actually changes. So you can see it's very simple to build a control panel utility that at the push of a button changes your entire scene. Very cool stuff. This control panel is not checked out from revision control, which means that it's going to inform me I can't save it, which is completely harmless but a bit annoying. So I'm just going to go ahead and jump into our revision control software of choice, Perforce, and check these out. There we go. Revision control is something we'll be coming back to, but basically there's nothing too proprietary in terms of working with revision control in Pixeltope. We like to work with Perforce to manage our assets and data files just because it's a very artist-friendly utility. But we've worked with creative partners who prefer SVN or Git or other free solutions. And those are perfectly suitable to be used for revision control with Pixeltope as well. So now that we are looking at the set, we of course see that we have a convolution-based bloom. Things are looking rather nice, but we are kind of missing sort of surface interactions. We have this glowy sort of waterfall bar, but it's not really showing up on the floor. Same over here, we have this beautiful crimson red roller, but it's not really shining off of these metal bars. And this sort of hot highlight down the corridor is not bouncing off the floor. The reason for that is we don't really have any reflections up and running. We could get pretty good approximations of these reflections using screen space reflections or planar reflections. We're actually using a planar reflection up on the talent position here, which you can see gives us very accurate but a bit too intense reflections of these physical spotlights up here. And screen space reflections have its own issues in that it can't reflect things which you're currently not drawing on your screen. So what that entails, we will be looking at when we do a deep dive into the different ways of doing reflections in Pixelop. But for now, let's just compare what ray tracing can bring to the table. So this is with ray tracing off, and this is with ray tracing on. So you can see it's completely night and day. You can see here these convex metal shapes now pick up the red from the red roller simply because they're now actually accurately bouncing light off the red field, which is being picked up by the metal. Same thing here on the floor. The blue of these waterfalls are now being correctly bounced off the tiled floor, picking up the color of the tiles as well as the roughness of the surface as it scatters and distributes and hits our camera, giving a much nicer physically accurate overall composite. You can clearly see it here as well. If we brighten these staircases, with ray tracing off, there's not really any per step interaction. We don't really have any ambient occlusion in the corner. It all looks a bit flat and gamey, which you can see here. As we bring the ray tracing back in, we get much warmer ambient occlusion because the light is bouncing between these warm wood tiles, heating things up and looking more natural. You can also see some of these slick chrome reflections on the talent podium. The moment we enable ray tracing, we get far more accurate reflections. So this is with ray tracing on, where we can see that we are correctly picking up the kernel-based flare from the light bleeding through these gaps. These shutters are colored correctly. They're darkened a bit by the dark metal that the rays are bouncing off of. And turning it off, it all just becomes mere approximations. You can see these triangles are far too bright. We also are getting incredibly sharp reflections from these small spotlights, whereas these big spotlights are being diffused in a completely different way. With ray tracing, all our lights are now correctly scattering in the same way. Same thing with down this hallway. With ray tracing enabled, the baked light on the wall now bounces off correctly on the floor, and as well as on these metal fixtures over here on the side. Now, I probably said the word ray tracing enough times to fill a medium-sized swear jar, so I believe it is time for us to move on. We can do other interesting things in this set. Let's pull back into our talent and bring up a virtual monitor. Using our proprietary video pipeline, we can pipe any kind of media onto virtual monitors. Now, we don't have anything set up on this monitor right now, but we can go ahead and, for instance, just pipe in the same video feed which we are using for our talent by changing the media video component's input spigot from 1 to 2. Now, if we do that and bring in our virtual monitor again, you can now see that we have kind of this gnarly Hall of Mirrors effect. Actually, we do not, because we are using the input, not the output. And we can also see that due to color spaces, we are not correctly converting this video signal. There's ways to work around this, but that is going to be beyond the scope of this brief overview session. So for now, let's move on by looking at how we could input another kind of feed. Oh, no. Now, instead of using an SDI feed, we could also go ahead and use a pre-recorded video on our virtual monitors. To do that, just go ahead and add a media video component. Instead of using an SDI feed down here, we're going to apply this to material 1, which is the screen, not material 0, which is a metal border. And instead of using an SDI spigot, we are going to use a debug texture. And the texture we're going to be using is going to be the show reel that we played at the beginning of this session. So now by hitting play, by bringing up our virtual monitor using our control panel, we can now go ahead and start playing a video segment. And we can see this video now playing back on a virtual monitor in real time. And this is a single virtual monitor, but there's nothing stopping you from having 2 or 4 or 10 of these all playing different video feeds if that is something that is applicable for your production. And we have looked at virtual camera moves on how to sort of leave a talent and jump to a new position. But we could also, of course, just animate the talent position itself without the virtual camera move, which we can do here by, let's say, just do a pedestal animation to push our talent to a new target position. Very good. You can see here that we accidentally left our talent behind. The reason for that is probably because our talent needs to be parented to our camera root, or more likely, we just need the blueprint that moves the camera root to also move our composition plane. So I'm going to select the pillar elevation blueprint. I'm going to add another element to be animated, which is going to be our internal composition plane. And now if we try this one more time, there we go. So just like that, we now shifted our talent position to the upper deck, where we have a much nicer view of, first of all, a smaller desk in the backdrop. We could even animate talent in between behind there if we so choose. And we also can pan around and get sort of a nicer high view of a virtual set. So that is more or less our virtual studio, or our template virtual studio environment. The last one, which we haven't looked at, is going to be our mascot scene, which is a useful example on how to do AR, as well as how to build and use blueprints, animation blueprints, to program a virtual character to do all kinds of virtual moves and actions easily triggerable through our control interface. So let's go ahead and bring up our mascot set, or a variant which we've built specifically for this Pixapalooza session. Before we do that, we're going to go ahead and ensure that we have our AR camera up and running again, because we're now, of course, going to be doing AR. So we'll just go to Setup, Routing. We're going to change our input feed from our green screen video feed to our AR video feed. There we go. And we're going to launch this back up in Editor. Or we could do it in Live for that matter. On this particular machine, yes, please. Very good. Now, earlier we briefly touched on the fact that we have an SDK and that you can use all kinds of ways of triggering actions and characters and logic within Pixitope. The SDK is mainly a way for you to compile your own plugins or other third-party plugins to function within Pixitope. It's very important to point out that this is a very harmless, fairly trivial process, because we strive for Pixitope to be as non-destructive and not degenerate any native and real functionality in any way, shape, or form. What this means is that, in short, anything that works in Unreal should work in Pixitope, including things like virtual reality. We've done several virtual reality productions in the past. Things like motion capture using third-party plugins. we've successfully used all kinds of different motion capture solutions and solvers. Just to mention a few, we've used the cubic motion phase solver. We've worked with the Xsense motion capture suite to do a lot of our motion capture, and there's not really been any extra overhead or complications in doing this. Whereas if you want to be using data integration in any way, shape, or form, that is most likely going to go through our custom API, which is based on Google's protobuf mechanism, similar to XML, but smaller, faster, and simpler. Data integration will be covered in great detail on, I believe that's going to be on Thursday. Yes, on Thursday, where we'll be using the open source Node-RED programming utility to showcase how we can take in live weather data and use that to drive weather effects within Pixeltope. But that is, of course, just one example. You could integrate Pixeltope towards anything as long as you're willing to do it through our API or a custom plugin for that matter. Now, this last set is our mascot set. So let's jump in. Again, we can notice that we have some color distortion between what we're seeing on my screen and what we're seeing in our output. As mentioned earlier, this is caused by our new HDR workflow, which was introduced in Pixel 1.2. This high dynamic range ready color management system allows for a complete HDR workflow, of course, which means that we can choose between using either legacy video mode compositing, which is kind of how everyone's been doing compositing in a reel, including us up until now, which is easy to use, but physically incorrect. As you can see in the production composite, let's zoom this out a bit, general tab, we have this video space option, which you can jump to on the fly. But we now also support linear space compositing. Linear space compositing, also known as linear light compositing or scene-referred linear light compositing, for those of you in the VFX or grading business, is a process of combining images in linear space, which more accurately simulates how a camera and an eyeball, for that matter, captures physical light. Among other interesting things, like ensuring that we can combine HDR values without clamping to white or black. It also allows us to do interesting things like use raw log formats from cameras or any other color space from that matter. The finer details of HDR is beyond the scope of this workshop, but for those of you that believe you need this workflow right now, or those of you that want to know more about it, please reach out and we'll provide you with some more material to understand the ins and outs of using HDR in Pixeltope. We can, of course, do more than just use HDR. We can also do all kinds of post-process effects and grading. This here is a bit flat, so I can jump into our color grading suite and start adjusting either our video or our graphics or both of them together. So this color grading suite is an incredibly powerful utility to help you ensure that your video and your graphics look like they belong in the sort of same world by having the same color temperature and the same color ranges. So I can see here that, first of all, my video looks a bit dark. Generally speaking, you don't really want to be touching video, but if for some reason you have the permission or it makes sense for you to do so, we can jump into video, enable color grading, and just start to fine tune our video a little bit. This particular case, I'm just going to pump the gamma and gain it up just to be a bit more welcoming, a bit brighter. Let's actually not punch the contrast so much so we avoid burning out the ceiling. There we go. I will then move on to 3D graphics, enable color grading here. And we are going to go ahead and just punch the gamma a bit. Let's also punch the contrast. Let's try not to gain this up too much, simply because we don't want to blow out our lovely mascot's chest. Let's instead just punch the contrast just to get some more interest over here with this foliage. Let's also, of course, jump back into our control panel to ensure we have ray tracing up and running. There we go. Let's see. So I believe we have a light source here, which is not behaving well. I believe that was me experimenting earlier. Now I could, of course, go into the go into the level in editor to resolve this light causing artifacts in the ceiling. But instead, I will choose just to go to our composite tab. We can here change between our lights. In this particular case, I believe it's going to be one of these lights. Let's see what happens if I turn shadow off. Yes, I knew it. Some experimentations just before we went live, which turns out not to have worked out. But luckily, it's easy to make all kinds of fixes and changes on the fly through the interface. So back to color grading. We can also, of course, use this to easily visualize exactly what is AR in the scene by going to our video and desaturating it, which is going to make all the AR pop, so it's easy to tell what is virtual and what is not. Very cool stuff. I think I will wrap this up by just adjusting my white balance of my foliage to be a bit colder, as well as desaturate it a smidge. And we are going to leave it at that. That's actually a bit too cold. There we go. Should always be a bit careful with your white balance. Now, all of this demo content is shipped together with Pixitope. So for those of you who have evaluation licenses or are going to receive evaluation licenses in the next few days, you can go ahead and go to login.pixitope.com to download both the Pixitope installer as well as our documentation and our demo content. We do have pretty elaborate, in-depth documentation, which you can, of course, access here. But you can also access this documentation directly from within the Pixitope directory interface to ensure that you always have help one click away. The documentation that is accessible here is offline, which means it might be slightly out of date, but it means you also always have access to it. If you would like to see our video tutorials or our more sort of live, guaranteed updated tutorials and documentation, simply open a browser, which takes you directly to our Confluence page, where you can start clicking through and at lesson page, where you can click through and look at whatever you need to be reading up on. Very useful stuff. It's worth mentioning that this documentation mainly is concerned with the ins and outs of Pixitope. We don't really cover Unreal subjects too much in depth. The reason for that is our friends over at Epic have, among others, there's also other training platforms which are absolutely stellar. But over at Epic, they have, first of all, a fantastic documentation available. Let's see here. Did I just take down my slides? I believe I might have. Oh, there we go. Yes, so Epic has incredibly in-depth technical documentation covering every aspect and functionality within Unreal, available over at docs.unrealengine.com. They also have fantastic video tutorials pertaining to how to use and how to get into Unreal, which you can find over at unrealengine.com/online-learning-courses. And I believe this more or less concludes our not so brief overview of Pixitope. Now, I know this has been a lot of data to take in. There's probably a lot of these interfaces that you're curious to know more about or want to see more in detail, but rest assured, we'll be covering all of these interfaces more in detail over the next few days. And for those of you that require evaluation licenses or would like to start playing around with Pixitope today, please contact your local sales representative, and they will be certain to help you out. So now, before we wrap up, let's do a questions and answer session. We are actually going to take a little 5-minute intermission just to ensure that all of you are able to get your questions in and that we're able to answer all of them in a satisfactory way. So the clock is now currently 6:36, so let's reconvene at 6:41, and then we'll be doing a Q&A before we wrap up this very first day of Pixapalooza. Thank you, and see you in a few minutes. Okay, everyone. I believe we are more or less ready to dive into the questions and answers. I will give all of you a minute or so to catch all your colleagues that might have run off to get coffee or do whatever you might want to do during a short break, and then we'll be diving into the questions you post. Let's also tell Dot to get out of there so he doesn't distract us during this Q&A session. Let's see there. And that's not quite the right button. That's not the one either. Is this the one? I need to label these. Close enough. So now that we have everyone back, hopefully, let's dive into Q&A. So let's see here. Some of you might, of course, realize that a question you already gotten answered is being repeated. This is mainly just to ensure that everyone else that might have been wondering the same gets to hear the same answer. So from the top, let's see here. So the first question here is, hello, are you going to record this webinar and send it to us at the end? Yes, these webinars will definitely be made available to all of you, because we realize that some of you might have had technical issues, especially since bandwidth has been so clamped all over the world these days. And also for those of you that unfortunately happened to join us a bit late, the recordings will be made available in the near future. Another viewer is asking, are we going to go through installing Pixeltope together, or should we start installing on our side? Well, obviously you can just go ahead and install it. The installing process should be very straightforward and painless. And if you're having issues during installation, they are probably going to be user specific and you might want to reach out. Next question is just confirming if the webinar recordings will be up. There's another recording question, and again, they will be sent out in the near future. Another user is asking, how can you jump between levels? Now that is a pretty big and exciting question, so let's look at a few different ways. So we are now, of course, in a level in editor, and we can choose to jump to a different level simply by launching it from the director. For instance, I could say I'm currently in AR backdrop. Maybe I want to be in my studio level. I could go ahead and just launch it either in live or in editor, or just switch to the level. Let's see here. And just like that, we switch to level on the fly. So I can go ahead and do that again. I can jump back to our AR backdrop by switching to this level. Pixeltope is going to load the level and then pop into this new scene. This is very good if you just want to very quickly bring up a new level without having to bring the editor down and back up again. But as you might have seen, there was a bit of a hang as we were streaming and loading in new assets, which means that you could do this during a cut or break, but you might not want to be doing this while you're live on air. But there's other ways of streaming levels as well. We briefly looked at this when we looked at our example levels here. We just bring it back up to explain what's happening. Something that's interesting in Pixeltope is that you can put levels inside levels. You can stream levels in and out on the fly during runtime. And you can basically bounce organically around between your levels using blueprint logic. So as we get this scene up, the scene is not designed to use ray tracing. So before we can launch it up, we have to ensure ray tracing is off. Just because the exterior New Dawn set is quite optimized, quite efficient, but not for RTX. It's simply too large. There's too many massive light sources. So let's launch it up in traditional rendering mode. While we wait for this to load up, the follow-up question was also whether it's possible to jump between projects. We can effortlessly jump between levels without having to close the editor and stream them in and out on the fly. But different projects means that you have to actually go here into Director and switch to a new project here. You can see here that if I just quickly bring in a new project, for instance, here, one of our calibrations projects, I can switch to this project, but doing so is going to forcefully close the editor because there's no way for us to jump to a different level in a different project without first closing the editor down and bring it back up again. But if we just want to jump between levels, we can see here that this is actually 4 levels we're currently looking at the same time. We have sort of this empty master level, which just contains some render logic, our track camera, a material handler, and a composite plane. And under this persistent level, we have a few streamed in sublevels. We have our mascot level, we have our exterior stream level, and we have our studio level. The way we bounce between these so far has been using our control panel, where in the Pixel Studio, I can choose to jump to the studio, outside, or to the mascot level. These buttons actually correspond directly to this blueprint, BP level transfer, which simply has logic causing a fade to white, or do this sort of fade to white transition. And while we wait for the levels to load, we'll be stuck with a whiteout. And while that whiteout is visible, we will be changing the visibility of these different sublevels. What this actually looks like in practice is that if I jump into simulate, we can see our scene, we can see our talent plane. As I click to a different set, for instance, the exterior, we fade to white. And then when the new set is loaded, we fade back into the new set. This could also be done in other even more elegant ways, for instance, by fading in a new level, but at a different position. Once the level is faded in, then we could do a virtual camera move to fly to the new position, giving us what appears to be a completely seamless transition where the load is not visible in any way, shape, or form. Yeah. Let's see. Next question. Did I mention sound effects with the rain? Yes, I most certainly did. Every time I go into this outdoor scene, which we are seeing here, I'm actually being blasted by a quite spectacular amount of bird tweets. I can hear the river running. And if I bring in the rain, I can hear the rain effects. Let's see if I can actually visualize this from the mixer. So you can see we're actually outputting some audio from Pixeltop. But sadly, we don't really have a way to pipe this into our webinar feed. But once you download these projects for yourself, you'll be able to hear all the audio output and use it in any way, shape, or form you'd like. Next question is, does sound go through the sound card or can it be embedded in the SDI output? All the sound goes through the sound card. We currently do not support embedding audio in the SDI stream. Let's see, next question was, when did we start this webinar? We started this webinar at 11 a.m. EST, as well as, which is 8 a.m. PST. If you missed the start of this webinar, please do not fret. You'll be able to watch the recording in the near future once we make it freely available. Next question is Pixeltop a free plugin in Unreal? First of all, it is, mainly it's not a plugin. Pixeltop is a standalone application which is built on top of, built into Unreal for rendering and effects. So it's not a plugin, it's a full custom version of Unreal. From the help menu, you can actually go to About, and you can see which version of Unreal we are currently based on, and which version of Pixeltop you are currently using. When it comes to the Unreal Engine, just as a bit of a segue, we tend to be pretty close after Epic in terms of their updates. We tend to lag roughly one version behind, which gives us the time we need to ensure that performance stability, and the user experience is where we expect it to be. Especially performance and stability has to be rock solid. When you're doing a live production in front of 100 or 200 million people, you cannot risk having your engines go down for any reason. The next question is, what is the approximate loading time of a project with a good level of detail, let's say for a TV studio of approximately 900 square meters and 4 cameras, or basically 4 different render engines, taking into account the continuity of use of the studio for various shows continued throughout the day? That was a very specific question, good sir. All projects, the first time you load them, have to build a cache. So in Unreal, you might, and in Pixeltope, you might notice that every surface, every geometry has certain material or certain look, whether it's cobblestone, dirt, grass, tiles, or brick, and so on and so forth. These are materials or shaders. Without these materials and shaders, you'll be looking at something that will be looking a lot more plain, as seen here. These materials and these shaders is what gives every surface a certain look, like whether it's foliage, whether it's brick, whether it's gold, whether it's metal. And all of these shaders are based on a typical metallic PBR or physical-based rendering workflow. However, these shaders or these materials, which are made using the Unreal Material System, needs to compile. This is an example of material, sort of a simple airbrushed metal. We have some textures coming in, piped into different output spigots. What we're actually looking at here is a node-based version of HLSL shader code. And for this to function, it needs to compile. If I am to make a change here, I save this, you can see in the bottom right, the moment this is saved, you will see a compilation window pop up. Well, in this particular case, this shader was so small and compact, we didn't really have time to see that pop-up come. But for more complex shaders, you will see every time you save or update the shader, you will have to do a compilation process. When you open a project for the first time, you don't really have a cache of pre-compiled shaders, which means that every single shader in your project needs to be compiled before you'll be able to jump into your scene. So the first time you launch a project can take a long time. For if you have a very unoptimized project where you're not using material instances, every surface has its own shader, this process can take 10 minutes, 20 minutes, half an hour in an extreme situation. But once this shader cache has been built, then you don't have to do that process again. So the second time you open the project, it will open incredibly quickly. And as you can see here, if I wish to open our exterior set, which is far more complex than any virtual studio would have any right to be. So here you can see I will launch my, let's see, needle, the Pixeltope exterior. I will launch this in editor. This set is probably using at least 500-600 different shaders, countless, probably 40-50 million triangles of geometry. And nevertheless, you can see it loads incredibly fast. Within 15 seconds of clicking the button, we are now in this heavy level. So pretty much any virtual set you are going to build will be loading faster than this, unless you're doing something drastically crazy. And the amount of render engines that you fire up in live at the same time doesn't really matter, because this process happens on each render engine at the same time. So whether I'm launching this level on 1 machine or 10 machines, the actual time should be more or less the same. Next question is, what's the, let's see, that is actually the same question. The next question is it possible to compose virtual video walls? And what are the input methods for these besides SDI? I believe we briefly looked at earlier. We can do a second cursory glance on that by jumping into a studio level. let's just bring this up. See here. Thinking about it, let's actually do this from scratch, just so we have a proper step-by-step walkthrough on how to do this. So let's go ahead and jump into a new level in my dev folder, which is ideally where you should be doing all your sort of experimentation and crazy shenanigans. So we've now created a new level. I'm quickly going to go ahead and give us a floor so we can see what we're working with. Give us a light source. And the last thing we're going to need is an actual video wall or a video display. So we're going to go ahead and drag in a plane. Let's give this a checker material just so it's easy to see what's going on. There we go. So of course we are going to be using, well, not of course, but in this particular case, we're going to be using a 116 by 9 aspect ratio video file, which means we are going to need a plane with that particular resolution. Let's make it a bit bigger. As you can see, when I try to scale this plane, we actually destroyed the aspect ratio. That's because of this handy little checkbox, which took me about 18 months to discover, tucked away under scaling options. Here, preserve non-uniform scale, which allows us to preserve non-uniform scale. There we go. So in order to do this through SDI, which we already briefly looked at, we can add a media component, which is proprietary for Pixeltope. It's part of our video input-output pipeline. So the most intuitive, most easy way of using this is simply putting this component on the surface. You then choose which material you wish to be applying your video to. And then we'll simply go ahead and choose the spigot that the video will be coming from, for instance, the output spigot. Now, when I simulate this, we're actually seeing a crazy hollow mirror because the video I'm piping onto this plane is the output from Pixeltope, which looks a bit crazy, but I hope this does make sense. I can also tell that this is upside down. There we go. But what if we don't want to use an SDI feed? What if we want to be using what if you want to be using a pre-recorded video file? Well, in that case, we are going to need a media player and a media texture. Let's name them because naming conventions are important. So the media player is the same as any other media player outside of Unreal and Pixeltope. It's service that plays video files of different formats and types, resolutions, frame rates. It plays video. We can open it and we can see that we can use this to play some video. Now, in order to play video, we need an actual video source. We can see we have a few in the project already, but we can just go ahead and make a new media source from media. So let's go ahead and use file media source video, which is going to point to a video file on disk. It's worth mentioning you can also use image sequences instead of video files, in which case the process is the same, but you would instead just be using image media source for an image sequence instead, which has certain benefits and is what we prefer to use. Video files are easier to use, but they offer less creative freedom. So here I open my media source, which allows me to point to a file path. And in the project, we have the scissor reel video at the ready. So I'm just going to select that, hit save, and we are going to see what happens if we try to play this media source. And there we can see our video is playing, including audio. Now, in order to put this media on a surface, we need a material. We already concluded that every surface in Unreal and Pixeltope requires a material, which means that we need a material, which I already have created here over on the side. This is a super standard empty material. I'm just going to open it, change the material type to unlit, so we don't have to worry about shading it or anything like that. And we're going to drag in the media texture, which receives video, or basically receives color data from the media player as the media player is playing. We're going to pipe that color into the emissive color, basically the glowiness of this surface. Let's see here. So we're just going to go ahead and let's get rid of this clutter. There we go. We can now bring our new material in on this plane. We can open our media player. We can play this media source, and we can see it playing back on the fly on this surface. Very cool stuff. It's worth mentioning that if you decide to play back video this way, you will notice issues very quickly. It might be hard to make out on the feed, but we can see that we have degraded the colors and the overall video feed looks very blurry. In particular, pay close attention to these rocks here where we clamp into black. Pay close attention to all these smaller details like the dust particles and these sort of granular insets in the rocks, which have just become mush. This is a result of trying to play this back using the native video pipeline, ensuring that a video suffers all the hazards of temporary aliasing, no MIP mapping, and so on and so forth. Instead, we are going to copy this plane over to the side here. On this plane over here, we are going to be using our media video component. Let's see here. Let's actually make sure we wipe this down. Let's just clear this. So we're going to be using a media video component with a debug texture, and that debug texture is going to be the media texture. So the overall workflow is more or less the same, but instead of using a material, we just pipe the media texture directly into our media handling component. And it might be a bit hard to make out due to compression, but this really helps preserve smaller details like text, individual particles, color space, and the overall look and feel of the video much, much better on the right-hand side. Now, this has all been done using a video source from disk, but we can also use, for instance, a web-based video file, like a live video feed. So here we are just going to see here. Now, I believe, see if I can find it. I believe I had a readily available web stream at hand, but I can't seem to find it. Nevertheless, in order to use a web stream, all you have to do instead of using a media source file, you would just go to media and use a stream media source instead, where you simply input the URL of your respective video feed. And that's more or less every standard fare way you'll be making a virtual video wall. And past this, then you can start making functionality to pause videos, rewind videos, seek videos, jump between playlists. None of this is particularly difficult, but it's a bit beyond the scope of this first session. Next question is, spec. I know the spec, but I'm just curious what box, or if there's a recommended or perhaps a preferred PC or laptop that you all travel with. We have a default machine spec that we suggest for people to use. As for laptops, those that give you performance are not usually the ones you would like to carry. But if you need sort of an in-depth recommendation for particular box providers or particular laptop models that we like to use for our demos, please again reach out to your local sales representative so they can present you with a list. I do not have that information at hand. Next question is, what is the limitations of the Pixeltope demo version or evaluation license? And that's very simple. There's no limitation. There's just the time you have. There's only the time you have the license for. Next question is, what is the key to decouple the camera? That is either F8 if you are in the editor, which will basically not just decouple the camera, but eject you completely from the tracked camera. So the tracked camera now exists here, but I'm flying around as if I was in editor mode. But if you're in live mode, this will not work because you cannot sort of eject to a simulation or editor view. At that, instead, what you can do is hit F10, which instead of ejecting from the tracked camera, actually hijacks the tracked camera. So I'm still looking through the tracked camera, but I'm feeding data using my mouse and WASD, allowing me to fly the tracked camera around to look at things. And when I'm done, I can hit F10 again to snap back to the tracking data, which is coming from our tracking solution. So the next question is, what's the time? Well, I believe we are a few minutes over schedule, but we can keep on with the questions we have left. Video walls, can they be HLS, RTMP, NDI, or other signals? All input media supported by the Unreal Media Framework can be used in Pixeltope. We just covered quite a few of those just now. We are adding NDI support in the next release. And you can also, of course, use SDI input feeds. Next question is, where do I download the demo content? And then I assume also probably the Pixeltope installer. You should talk to the person who signed you up for this webinar. They can set you up with the trial license, which will give you a link to download the software. If you already have a trial license, then you can go ahead to login. Then you could go ahead to login.pixeltope.cloud, which is where you can download both Pixeltope as well as our example content. Sorry, login.pixeltope.com. The next question is, we are a US-based company, but due to, let's see. Oh, that is not relevant here. You had a slide earlier with the hardware blueprint/routing. Is it possible to show that again? Absolutely. Let's just dig into our slides, go back. I believe you are either talking about this slide, showcasing how you would fit Pixeltope into a different studio setup, or more likely you're thinking about the particular studio setup for this studio we are currently using. That's this slide here. We are using two cameras, one in our green screen studio and one in our AR studio, separated by about 50 meters. We are using two machines, technically two render engines, but only one of them is doing any rendering. The machine located in the green screen studio is simply receiving the raw tracking data from the camera to its local camera tracking server, which is then passing that processed tracking data to the render engine, which I'm currently operating. And this render engine is also receiving the raw SDI camera feed from both cameras, as well as the raw tracking data from the Moses tracking system over on the side here. And we are using that to jump between our scenes and generate all these beautiful final composite images, which we are then outputting to our webcam feed, as well as my screen share below, as well as the SDI to webcam, which you're seeing over on the side, and which all of you are seeing right now. Let's see. There's a question, could you send the link to the supported formats? This person has already received the answer, but these formats can be found, I believe, underneath. Let's see. You Probably find all of these on the documentation for Unreal Engine, docs.unrealengine.com. If you search for, let's see, yeah, I'm not going to spend too much time digging around. I've seen it in it before, but this is where you can find all the video format specifications, which also pertains to sort of experimental features like using HAP codecs for alpha embedded video. So we also have someone asking about off-axis camera projection and how we use it. As a brief reminder, off-axis camera projection is what we just saw earlier. Let's just go into a slide. It's basically the act of using Pixeltope to render an output, allowing you to use any display or video wall or projector to act as a portal into virtual graphics. In order to use off-axis camera projection, there's not a whole lot you have to consider. Let's see. First off, let's jump into a placeholder level. There we go. First of all, let's see. If we look at our video feed here, we can see that we have over here a banner. Let's just use let's actually not look at the banner. Let's look at this back wall, which has a aspect ratio not too far from widescreen. Let's now pretend that this back wall is actually a giant video wall. So then what we need to do in order to be able to render off-axis camera projection output to this particular back wall is we need to put an off-axis camera projection actor. Let's see, let's go in here to Pixeltope and pull in an off-axis camera projection plane. Let's grab, here we go. Also, Magnus, could I possibly pester you to try to measure the height of that wall? It's going to be a bold quest, but what you need to do is basically measure the exact distance from your camera to the video wall, as well as the exact dimensions of the display you wish to generate off-axis camera projection to. These measurements have to be accurate. Just being an inch or two off will completely destroy the effect. So we are, of course, we're going to play this a little bit by ear, but just to sort of showcase how you could go about doing this. So we measure the height, 232. We measure the height of the wall, which is 2 meters and 32 centimeters. Let's put that in this one instead, 2.32. There we go. I'm going to ensure that this touches the ground. To do that, I'm just going to move the pivot using middle mouse button and hold V to snap the pivot to a corner vertex. Then I'm going to go to pivot, set this pivot offset, so now I can just scale from this point instead. I will hit end to snap my plane to the ground. And now using VSUBIG, I can easily slide this to match up the position of the far wall. So let's go ahead and enable AR in the scene so we can kind of see a final composite output. Let's take the floor and just convert it to a shadow catcher so it doesn't show up in our output. And now could you possibly change that feed to my output feed? Bear with us for a second. There we go. Now you can actually see what I'm seeing in my reference monitor. I can use this now to quickly slide this segment into place until I can see it's touching the wall, lining up pretty well. Now we did bump into our camera earlier on during setup, so this is probably not going to line up 100%, but we'll do as best we can in the little bit of time we're going to spend answering this question. Yeah. There we go. So now that we more or less sort of matched up our video wall with a geometry, which now seems to be, this distance seems to correspond with what I'm seeing over here from the camera. I'm now going to go ahead and just take our off-axis window and just position that in the same position and scale it up. So we paste this in. This is by default locked to the aspect ratio of your output feed. We also have to copy the rotation. So what I'm doing now is I used a white plane just because I can see it in the output to quickly line it up with the wall. And then I'm taking all the parameters and pasting them onto this off-axis camera projection actor just because I can't actually see it in my output feed because of the type of actor it is. There we go. I'm actually surprised by how close this wall is to a perfect 16:9. Interesting. So now we've got our off-axis window lined up pretty well with the wall. So now we can delete our reference. You can also see it's backwards, so I have to flip it around. There we go. And this is our initial setup. The last thing we have to do is go to Edit, Project Settings. We search for Player. We have to change the local player class from local player to off-axis local player and restart Pixel. This is all covered in our documentation, but for now, let's just do this manually. We're also going to put a cube in behind here. We're going to go ahead and restart the level. Give this a second to fire back up. And now, if I am to jump into live mode, what we are seeing now is basically, imagine if you're looking through this camera, you are basically taking what this camera is seeing, which is going to be basically using the edges of this off-axis plane as a frame to cut out whatever is within this frame from the point of view of the camera, hence off-axis camera projection. And then you are remapping that to be laid out in a perfect 16:9 output feed. I know this might all seem a bit abstract, but hopefully we can visualize this in a way that makes sense. So let's quickly bring in the geometry. This is also going to be a sneak peek at some of the characters we're going to be looking at tomorrow. There we go. So here we're going to put this character directly behind our off-axis camera projection window. So what we can expect is that as we are looking at this wall or display wall from an extreme angle, in order to get to render this, which is going to look like this talent standing like this, if I projected this image onto this display, we would be seeing it extremely distorted from this point of view. And we can actually visualize that by moving the camera root over here to the side. Now, if you can try to imagine taking everything inside of this blue rectangle and stretching it using a morph tool to fit a 16:9 image, you'll be, let's see, let's pull this out a bit. We also, of course, have to go ahead and turn off lens distortion. Because lens distortion and off-axis camera projection simply does not make sense for a plethora of reasons. File camera. See here. Oh, I see. I just realized this is actually sideways. That explains why I was seeing mysterious things. Let's see if this works. There we go. Sorry about that. I accidentally put my composite plane upside down, but now we are finally at home destination. So again, imagine now that you are going to take this blue frame and stretch this to fit a plane, which obviously is going to cause extreme distortion to this person. And if you go into play mode, this is what we are seeing. If this video feed was output to the video wall, which will be in the back wall in our studio, while the track camera was looking at it from extreme angle, this output feed to the video wall would look correct from the point of view of that tracked camera at this angle. That is more or less how you set up off-axis camera projection and how you use it in a day-to-day basis. It's worth mentioning that this integration is proprietary for Pixitope. We are not using NDisplay from Epic. And if you're looking at extreme use cases of how this technology can be used, feel free to go look at wave systems used in all kinds of VFX, as well as the gorgeous off-axis camera setup created by Lux Machina for The Mandalorian. This is, of course, a far more rudimentary solution, which mainly works with planar surfaces, but is also very easy to set up and very robust for day-to-day off-axis camera projection use cases. Now, I don't think I can say off-axis camera projection one more time, so I think we're going to move on to the next question. Next question is, I'm carrying an older Alienware as well as an MSCI 17-inch with a slower graphics card for most of my on-the-go development. I'm trying to justify more investment. As long as you don't really worry about hitting a target frame rate, you could run Pixitope on quite a wide range of specs, but of course your performance will suffer. If you're going to re-equip, we strongly recommend you look at the newest RTX capable cards from NVIDIA. You will absolutely not regret it. Next question is, if you wanted to bake adjustments after going live in your Unreal scene, is it possible to do that? Yes, there is a bake button in editor. It's this button up here. We can actually see that button in action if I simply hop into director, go to production, adjust object, and I quickly just go ahead and grab, let's see, the off-axis window, for instance. I just move it out a bit, just like that. Of course, if I'm not in play mode, then these settings are automatically baked because we're assuming that if you're not simulating the game, then you wish to keep these changes. So let's simulate. We move this back out, hit stop. And I'm very lost right now. There we go. We can now see that the off-axis camera window has moved forwards. And I could just go ahead and bake that. Sorry, yeah. So I moved it forwards, but we were seeing the original position. But if I bake, we bake down the position that we just offset to in director. So baking is trivial, easy to do. It's a single button solution. Just make sure you save your level afterwards. Next question. Running a live event, do you need to have the editor open? No. There is a dedicated live mode we've been using a bit, which removes the UI and therefore also gives you a bit more performance. We can access that by simply here firing up, for instance, our sort of default AR backdrop scene and launching it live. That's not the one I want this one. Which brings us directly into a live view with no option of accessing the directory interface in the editor interface in any way, shape, or form. So now we are in a standalone live mode, just like that. Can you wiggle the camera a bit? This also has far more robust tracking. The sync is guaranteed to be better, and this works far, far better, especially with interlaced video signals. So whenever you're about to actually go live, you should always be using the dedicated live mode option. Next question is, would it be possible to use a webcam to test a virtual studio scene? Yes, using the Unreal Engine Media Framework. Now, this is the second person that has asked about the media framework, so I'm just going to see if I can quickly find it. Let's do another try of this. Let's see. There we go. So if you go to this URL, or if you simply go to docsunrealengine.com and you navigate to engine features, media framework, here you can see all the different ways you can access the media framework within native Unreal, and how you can feed in videos of different formats, which formats you can use, how you go about doing it, how you would be handling video files with blueprints. Basically, anything you would like to do is covered in great detail within this documentation. How to control your playback, what kind of do's and don'ts you should try to do and don't, which formats you might not want to use due to excessive compression, how you would use image sequences, how would you use media playlists, so on and so forth. Next question is, when I use AR, can I make the person who is cut out in chroma go forward and behind the graph if I'm using NCAM as tracking? Yes, absolutely. There's multiple ways to combine. Well, there's one way to combine AR and Visual Studio, which opens up a lot of interesting use cases. If you want to be able to walk around graphics, then you're going to need two things. You're going to need a way to track your talent, ideally, so you know whether the talent is deeper or closer to the camera than the graphics. And you are going to need a key, so you know where the silhouette of the talent is. You can make do without a key by instead using multiple composition planes. We can spend a few seconds looking at that right now. Let's jump here into our sort of AR setup. We don't actually have an AR setup level, so let's just go into any level and create a new example. That's okay. What's this one? Oh, I might have been clicking a bit too aggressively there. Yeah, this was still loading. So let's just quickly relaunch this. Button mashing never helps anyone. There we go. So we're directly back in. We're going to launch the level in the editor. And we are going to basically create a new scene. We are going to set up AR and Visual Studio at the same time in order to allow us to quickly shuffle a talent in front and behind our graphics. So first off, back to director setup, we are going to go to routing. We're going to be using our green screen camera. There we go. Then we're going to go to my developers folder and make a new level. We actually already have an example of a setup for this, AR and Visual Studio. So in order to enable AR and Visual Studio at the same time, we need to go to World Settings, search for AR to ensure AR is active. And Visual Studio is active by default. So now we have VS and AR at the same time. Now, what I next up can do is, let's convert this floor to a shadow catcher. Could we change this output to show the actual camera output? So we are going to pull in an internal composition plane and position our talent on the green screen. Same procedure as before, we just pull away until the edge of our talent lines up with the ground. There we go. And the cool thing, as you can see, is since we are now using AR and Visual Studio at the same time, let's get rid of this for now. We can see here that I have my talent on my composition plane, but I also have an AR backdrop, which is infinitely far away. So now we can do some interesting things. I could now, for instance, pull in a character, like character we were just looking at. We can put one of these directly behind our talent. Let's give him an animation so it looks a bit more lively. There we go. And we can take this same graphic and put in front of our composite plane as well. And as you can see in our final composite, we now have layered graphics in front of and behind our talent. Of course, since we are doing this kind of layered vs AR, we can also go ahead and go to video key here, just kill our D-spill, just so we have a nicer looking composite. Let's also ensure we're doing this in linear space. Very good. And just like that, we've now layered graphics in front and behind our talent. There's many other ways of using this combination of VS and AR as well. For instance, if you want to have a set which is half and half green screen and physical set, and you want to use AR in the physical side and then allow the talent to walk into the green screen, which could be a virtual set extension. That's also the more typical use case of when you would want to combine AR and Visual Studio into a single level. I hope this more or less answers your question. Next question is, if you want to add more camera profiles, what's the way you go about doing that? You can definitely add your own camera profiles. It's very easy. All you have to do is go into Director, go into your camera setup, and just specify the horizontal and vertical sensor size. So you add a camera type, and you specify the data here, as well as give the camera a name. Next question is, what about makeshift tracking software? I'm not sure what you mean by makeshift, but if you are jerry-rigging some kind of tracking solution which is able to output 3D, which is sort of the standard open tracking protocol that quite a few solutions use, then we have no issues ingesting and using that within Pixeltope, though you might want to do a bit of setup calibration to ensure your tracking sticks. What can Pixeltope do about actor occlusion? We do support object tracking input, for instance, using Stipes followers, which can drive the position of the internal composite plane, allowing to dynamically occlude graphics with your talent. Or you could do it manually like we just did, where you physically set the internal composition position, and then you just layer the graphics in front and behind as we're looking at right now. Now, in order for this to look good, we're probably going to have to play a bit more with our key, but we are, as a conceptual idea, I'm sure this gets the idea across. Next question is, what is the demo duration? The demo duration is 2 hours, so we're actually almost 40 minutes over already, but there's been so many great questions, so I really do wish to push through and get to as many of these as we can before we have to wrap this up. Next question is, can you input a physical controller, for instance MIDI, into one of your computer interfaces to switch levels? This is all possible using Unreal Blueprints. For some demonstrations, we've even used a clicker, like a single button Bluetooth clicker device, allowing the presenter to control the graphics by themselves to jump between different slides or different segments of the Pixeltope rundown order for that particular show. As long as the device can be mapped in Unreal, we can easily access the controls of this using native Unreal logic. If it cannot be mapped in Unreal, then it might be time for you to look at either our SDK if you want to make your own plugin, or our API if you wish to be feeding in this controller data through Protobuf. Let's see. Next question. Is it possible to transfer assets, levels, or blueprint information I've started in Unreal to finish in Pixeltope? Yes. There's not even any transfer. All you have to do is find your Unreal project. You add the path here in director, add the project folder, and you launch the project. Now you're done. If for some reason you want this Unreal project to be separate, you only want to transfer some files, you can easily do that as well. For instance, by finding the particular assets you wish to move over, like let's say I want to move over these parts of the skeleton mesh for Dot or mascot. You would select these in Unreal, right-click, go to Asset Actions, and simply do a migration action, which will allow you to move these actors, as well as every actor they depend on to function. So this is a skeletal mesh which requires some materials. Those materials require textures. The skeletal mesh also requires animation blueprints and animation assets. So grabbing these 4 actors will migrate all of the actors we see in this list. And then you simply find the Pixeltope project and the content folder of that project, which looks like this inside any given Pixeltope Unreal project, and simply select the folder to migrate those assets. So there's multiple ways of doing it. It's very straightforward, and it's not proprietary to Pixeltope. Next question is, Unreal updates constantly. How often does Pixeltope update? We do track the epic releases, but we don't aim to coincide. We allow the new releases because we try to stabilize and focus on Pixeltope being as stable and reliable as possible. But we definitely do come out with versions rather frequently. We are currently supporting 4.23, and Pixeltope 1.3 will be supporting 4.24. And given that Unreal is currently at 4.25, that means we're not really far behind at all. Next question is, what's the differences between live and artist licenses? Live licenses gives you access to all functionality within Pixeltope, whereas the artist license it basically disables video input-output, at least SDI input-output, as well as tracking input-output and multi-machine control. So the artist license is mainly for working on your graphics, and then you would go to a studio machine with a live license to test your graphics with a tracked camera. We also have a third license type called a remote license, which more or less only supports the director. It doesn't give access to the editor. The remote license is mainly for setting a machine to act as a remote control interface for your Pixeltope network. Next question is, can you assign a MIDI controller to a control panel? Yes, providing the keys from the device can be mapped, we can use them to trigger events in control panels, etc. Does Pixeltope support all of the built-in plugins that ship with Unreal? The answer to that is a bit complicated. We support most of them, but there are some which are game-specific that we've decided to remove for one reason or another. And again, if there are third-party plugins you also wish to use in Pixeltope, then they will have to be compiled against Pixeltope using our SDK. Is there a preferred video file format and codec for the media player? Generally speaking, H.264 encoded video files in MP4 containers or Matroska are generally recommended. We also have good experiences using the HAP codec just because it supports alpha in live use. It's worth mentioning that certain codecs have limited functionality. Certain video formats will not, for instance, allow you to play a video backwards, rewind, or seek to particular time slots. So we strongly recommend you experiment with different codecs to ensure that you stick with one that works for your use case. H.264 encoded MP4 files is a good place to start. You can also never go wrong with image sequences, which, despite being a bit more performance heavy, offers unlimited creative freedom in that you can jump between images on the fly, you can play forwards, play backwards, and really go to town with how you choose to operate that media. Is there a list of recommended naming conventions for assets like media texture video, media source video, and so on? Yes. We have a style guide which is very closely derived from Alar style guide, which is something we are going to cover in more detail on Thursday. But if this is something you're interested in looking at right now, then you can actually look at the Alar style guide on your own. Simply Google Alar style guide, and the first GitHub result is going to be what you're looking for. This is the style guide we're using, which is an absolutely brilliant style guide showcasing both why you wanted to use a style guide, what using a style guide entails, as well as what the actual naming conventions and folder structures for your Unreal projects should be. So here we can see there's rules for all the different actor types. Skeletal meshes are SK, static meshes are S, textures are T, animation blueprints are ABP, blueprints are BP, media textures are MT, and so on and so forth. It's very, very extensive. It covers every basic actor type within Unreal, and it's a great place to get started if you just need a style guide. And in case you were wondering, yes, you do need a style guide. Everybody, especially people working in teams, need to be using a style guide. Otherwise, your project will quickly grow out of control and become intertwining, horrendous messes to work in. A style guide ensures that a project looks like it was made by a single person, no matter how many artists and engineers are working on it. It's a great way to enforce strict conventions, and it's a great way to ensure that things never spiral out of control. It's not really important what your style guide is. It's more important that you have a style guide and that everybody in your team follows the style guide. Next question. Are there any plans to support NewTek NDI as a texture or camera source? I believe that has popped up a few times. I'm glad to see there's so many that are interested in NDI because NDI will be supported in our next release. So that's something for you, all of you, to look forward to. Can you trigger a pause video in the interface or via an URL interface on set? Absolutely. Pausing video is fairly trivial. We can look at that right now. So here, let's see, we have Dot that comes in and plays a video through his chest. Let's open the blueprint for Dot. Let's say that for some reason we also wish to be able to pause this video, which is being played using this media player, which is opening the show reel in this particular case. We can quickly go in here and make a new custom event, call it PX pause media. There we go. We are just going to copy the reference to the media player, and we are just going to go ahead and pause this media. And just like that, if we hook this up, this will allow us to pause the video with the click of a button to the control panel. Now, this of course will mean that we're pausing the video, but we can't start it again. So let's actually, instead of just pause, let's call this PX pause toggle. Or actually, let's do this, PX pause. And with this event, we're going to pass a Boolean value, like a true or a false. If true, we're going to pause. If false, we are going to unpause. We're going to drag out this Boolean into an if statement. So if this is true, then let's get this media player again. If it's true that we need to pause, then we are going to pause. And if we are not supposed to pause, if we basically want to resume playback, then we're just going to resume playback. There we go. So now we just add a little extension to this already pretty crazy blueprint. This is going to be play, pause video, compile, save. That's fine. Save it. And now that we have this logic, we are also going to add a new button to our director interface. We're going to go to production. We're going to find our mascot interface. We're going to edit this control panel, and we're going to add a new button widget. Actually, no, we are going to add an on-off switch. We have a few other widgets here for inputting drop-downs where you could set up like enumerators if you're doing election graphics, allowing you to maybe choose between different counties or politicians or states. Text field where you can type in text and pass it to a text element or anything else really. Numeric input fields, labels to help organize your control panel, as well as a trigger if you just want to click a button that does something. So here we're going to make it on off. We'll just tuck it over here. Right click, edit the action, play, and pause video. Very cool. Active state is going to be red because that means we paused. Off state is going to be unpaused. And the target for this is going to be BP Pixitope mascot. We select the blueprint. Let's see here. We might actually have kept, let's see here. Yes. So this blueprint has grown a bit too much, but that's no worry. We are just going to take this logic and we are going to pull it out of the mascot and put it in a dedicated blueprint instead. So I'm just going to make a new blueprint here. So what happened here is that this blueprint has sadly not really been maintained in a while, so it's just gotten a bit too bloated. So I need to segment out a bit of the logic. So here we're going to make a BP pulse video blueprint from scratch. We'll simply open it. We paste the logic we just created. And we also need a reference to this very same media player. So I'm just going to make a variable, which is going to be a media player reference. Media player chest. There we go. Compile it. Let's delete this stale reference and use our new hot reference instead. Plug it in. And this is going to access the same media player as the mascot is currently using. So this new blueprint can interact with dot. We pull our pulse video logic into our scene. And we will try this again. So now the target is, instead of the mascot, is going to be pulse video. And the function is going to be px pause. On means that we want to pause. So on should be true. You can see how we're basically passing a Boolean statement. On is true. And off is false. Save, apply, save. Let's try this out. Again, we are now in an AR scene. So again, we've seen this quite a few times, but you can never see this too many times. We shuffle back to our AR camera and we change our SDI feed. Then we are going to go to our production tab. We're going to bring in our mascot. We're missing some holdout for this lamp. I could have built some, but I wasn't expecting to see that. Let's open this chest and we can play the reel. There we can see the reel playing. And now using this new button we just created, I hit pause. We're pausing the video. Unpause, unpause the video. Pause, unpause, pause, unpause. We can even open this blueprint that we just created and we can see, as long as we're still simulating or playing the game, we can actually see the logic firing off and follow the execution order during runtime. This is insanely useful when trying to figure out why your blueprint is misbehaving or why unintended behavior is happening. Very, very cool. Okay. Next question. Is it possible to is it possible to all 3D views? Can 3D views be orthographic? Is it possible to use different kinds of 3D views? The answer is yes. The hotkeys, you can actually do that from within the viewport in the top left, hitting this drop-down where you can choose different perspectives, or you can just use the respective hotkeys listed on the side. So here we can see front view, top view, and left view, and so on. You can bounce seamlessly between orthographic views. The first time you go into them, you'll be seeing them in wireframe mode, but there's nothing stopping you from seeing these in lit mode, seeing them unlit, seeing them which is in wireframe, or seeing them in standard lit mode. It's worth mentioning though that some shaders will behave differently when you're looking orthographically at them, just because looking at something from an unidentified distance means that certain distance-related material effects, like for instance the subsurface scattering in the plastic exoskeleton of the dot, starts going a bit crazy. But nevertheless, this is really, really good for just aligning things. And also here we can see it from top view. If I just hide the ceiling, this is very, very simple and easy to use. We have orthographic views, but we also have different ways of viewing graphics. We covered wireframe, unlit, and these different render modes. We also have useful render modes like reflection mode to see what we are basically able to reflect from every single polygon in your scene. Very useful when you're trying to set up your ray tracing reflections. We can have by hitting Alt-7, we can see light complexity, which is a good debug utility to see where do we have too many overlapping dynamic lights killing a performance. And jumping into Alt-8, we can now see shader complexity, showing us which shaders are too heavy and potentially tanking our performance. You can also visualize the individual buffers, which are notably being used in our render pipeline from world settings. And you can change the visualization mode to look at all the different buffers used in our composite pipeline. This is probably a bit more of a power user functionality, but it can be fun to play around with if you're trying to figure out how does something work. Next question. Is there any manual or is there any way to be able to read up on Pixeldope at your own leisure? Yes, all manuals are available in Pixeldope. You can access them, as mentioned earlier, from the director in the documentation tab at the bottom. Again, this is an offline documentation, so it might be a bit out of date, but you can access this at any time, even if you're not connected to the net. If you are connected to the net, then you can simply access our Atlassian page here, which also can be accessed using docs.pixeldope.com. In regards to off-axis projection, there is a separate page for that in our documentation. You might just have to dig around a bit, but I believe you already received that particular link. Next question is, how can I render a 3D object in front of my actor, like a front plate and a back plate effect? We don't really have a concept of a front plate and a back plate effect. What I mean by that is, what we do is we put everything together in a 3D space, including our video. Our video is being projected onto an internal composition plane, which then lives within a 3D space. This means that in order for something to be in front of a talent, you just make sure that graphical element is in front of the composition plane, and vice versa. To put something behind, it has to be behind the composition plane. There are ways to forcefully force certain actors to render in top or in behind. using custom depth stencils and post-process materials. That's probably going to be a bit more of an advanced use case, so I will not go into that now, just because it's already getting very late. But if that's something you desperately need to see, please contact your local sales representative so they can file a ticket and we can show a use case which matches what you would like to see in detail. Because there's probably quite a few different ways of going about doing that. Next question is, other than the marketplace, is there a bank of assets, monitors, charts, and displays, etc., being offered by the Future Group? The answer to that is no. We do not sell assets, but any model asset that works in Unreal, we work in Pixeltope. It's also worth mentioning that we don't really have a large library of assets, but there is, of course, the Quixel database of photorealistic photogrammetry. There's, of course, other marketplaces like for architecture visualization models, as well as generic 3D models from marketplaces like TurboSquid and similar. And what we do offer with Pixeltope is our 3 main demo sets, as well as what we call the Pixeltope baseline blueprint system. We're definitely not going to go into that today, but it's basically a library of blueprint tools and widgets to help you get into setting up very complex triggerable logic within your projects without having to build all of this logic from scratch. This is going to be covered, I believe, on Thursday. Okay, so I think at this point we are going to have to stick a fork in it. We are now 1 hour over schedule, so I think we sadly have to wrap it up here. These are the questions we had time to answer. But before we say our final goodbyes, we'd just like to say that our next session starting tomorrow is going to be covering augmented reality A to Z. We are going to be looking at how to create and use augmented reality in Pixeltope, how you structure your scenes, how you use the different render features and compositing utilities in Pixeltope to ensure you have a clean combination of graphics and video. We're then going to branch out into more advanced masking and ray tracing techniques, as well as more complex render features like light wrap and similar. And at the end, we're going to wrap up with a practical use case, which is going to be virtual characters, as well as how do we control them and interact with them using our control panel interface. So I think on that note, we are going to say our goodbyes. Thanks to all of you for joining us and sticking with us for so long. We apologize that we went a bit over schedule, but we do hope to see all of you again tomorrow. Until next time, goodbye.